Okay, so first, during advisements, there's going to be a readiness check for the PSAT. But just to make things easier, and you guys will stay with me today. We'll do readiness check so there's not all the movement during advisement. So just be with me for today, and then we'll go back to our regular schedule tomorrow. Also, tomorrow, when you guys go to advisement, make sure that you are reporting to 2204 because she's taking Ms. Moore is taking attendance, and if you have a permanent pass, make sure she knows about it because otherwise, if then she's going to think that you're skipping, and then there could be a write-up. So just make sure that if there's anything that where there's a pass or you have to be somewhere, let her know so that she can. So she's able to make sure her attendance is correct. Okay. Now let's talk about our calendar here. So we've done two topics already for this unit. We've done extreme value theorem, which is finding max and min. We've done mean value theorem, which is taking the slope, taking the derivatives, and them equal to each other and solving for x. I think the first derivative test is going to be a relatively easy topic because you've already done velocity sign lines, right? You've done velocity sign lines, and so that's basically what this is. This is just the velocity sign line, but instead of velocity, it's the first derivative function. So instead of moving right and left, you're just thinking, is the graph going up or going down? So it's virtually the same process as particle motion, which is our thinking in terms of the graph instead of thinking left and right. So that'll be today. Tomorrow, we're going to be involving the second derivative function, which is telling us about curvature, but it's the same process. We're still creating a sign line. We're still finding critical points. And then there's also another test called second derivative test, which is another way to find max and min. So after today and tomorrow, we're going to have covered all the topics that we need for our quiz. So I think we can start our quiz review on Friday and Monday, but I just want to give a little bit breathing room here. So I want to just flip these days around. So the quiz, I want to make the quiz on Thursday. We're still going to cover 5.4. This is basically putting it all together. This is not going to be technically on the quiz, but this is still a good review. And we can also do more reviews second half of class. And PSAT day, there's no classes that day. It's just students who are going to take PhD will be taking it, but it gives you another day to review for Thursday. Okay, so that will be our schedule. And then Friday we'll continue beginning the second half of the unit, and then after fall break we'll just be able to begin our test review for that unit, and our test will be that Friday after fall break. After this, we only have 2 units remaining. We'll have logs unit, we'll have the trig unit, and then that'll pretty much be it for our semester. All right, so.
Wait, just doing this for the semester, not for the year, or for the life.
Right. We have after we finish this unit, we'll have logs unit and trig unit, and then that'll take us to the end of the semester.
Oh,
yeah. Okay, so let's turn to page 14. A lot of these notes will just feel like it's familiar. We know that derivatives represent the slope of a tangent line to a function curve. Whenever the function is increasing, we know f prime is positive. So f prime positive means positive slope. That means the graph will be increasing. if f prime is negative, we know f prime is references derivative, which is slope. So when f prime is negative, our function is decreasing because we're going to be experiencing negative slope. And then we're just going back and forth here. When f prime is greater than 0, if my slope is positive, my graph is increasing. When f prime is less than 0, that means my slope is negative. If my slope is negative, my graph is decreasing. Remember, we always read the graph from left to right. So we always read the graph from left to right. When f prime is equal to 0, that means my function is a constant, or that there's a horizontal or changing direction. So f prime is equal to 0 could look anything, any of these variations. So this is a slope 0, this is a slope 0, and this is a slope 0. So slope zeros are a lot of times what we're looking for, because this will lead to potential max and mins. A lot of times we're looking for max and mins, but relative max, relative mins don't occur everywhere where f prime is equal to 0. But f prime is equal to 0 is a good candidate for us to look to see if the graph will be a relative max or relative min. We have a bunch of steps here for the test, the first derivative test that we're going to do, but I think it's easiest to just go through the example and just kind of walk through the example so you can see it. So, but it's going to feel a lot like particle motion, right? We're basically doing the same thing, but instead of calling it velocity, we're calling it f prime. Okay, so let's go to example 1. Example 1 says determine the interval where the graph is increasing and decreasing. Locate the relative extrema. So what we're going to do is we're going to just find the derivative, find the critical points from f prime, set f prime go to 0. Very much like how you were doing the velocity sign line, right? You will find the velocity function, set velocity go to 0, find critical points, populate the sign line. Exact same process. So we're going to find f prime. Power rule for each term. Bring down the 3. What do we get? Yeah, 3 times 1/3 is just 1 x squared. Next term, 5 halves times 5 halves x squared becomes because when the 2 comes down, the 2 and the denominator will cancel that out. Okay, minus 6x becomes, and then the negative 3, 0. Okay, so we have our f prime. Next up, we're finding critical points. So set f prime equal to 0. We're looking for places where the slope is 0. Go through factoring. Multiplies to be negative 6, adds up to be 5. What two numbers? 6 and negative 1. Okay, solve for x, we get x equals what? 1 and negative 6. Okay, so instead of calling this a velocity sign line, we're going to call this the f prime sign line. Okay, you're going to place your critical points onto your f prime sign line. You're going to choose values to test in each subinterval, just like how you're doing a velocity sign line. So I'll choose negative 7, I'll choose 0, I'll choose 2. We're going to test this against the f prime factored form. You can plug into either, but I like factored form. It can allow us to do it calculations faster without a lot of number crunching. So negative 7, and for x, negative 7 plus 6 is a negative, right? Negative 7 minus 1 is negative as well. So 2 negatives makes positive. So you're going to put a positive here, but then we want to kind of indicate the movement of the graph. So whenever you see a positive on the F prime sign line, that indicates positive slope. So I'm going to draw an arrow pointing up to indicate positive slope. And that kind of gives us a quick visual how the graph is moving. It's rising. There may be it may be different levels of slopes, but it's all going to represent positive slope. Next up, x0. So 0 and for x, positive or negative. Now 0 plus 6, positive times negative, it will be negative. Okay, so put a negative in that interval, and then you know that there's a negative slope throughout this entire interval. So draw an arrow with a negative slope to indicate how generally how the graph is moving. And then we'll test 2. So 2 in for x. Positive times positive. 2 positives makes positive. So the graph is going to have this shape. It's going to rise, hit slope 0 at -6, falls, slope 0 at x equals 1, and then rise again. Okay. Right now, we don't know the y values, but we know how the graph is moving. So what can we conclude then about what's happening at -6? There's a what? Yep. And then what visually, what's happening? There's a what? Relative max. Good. And then at 1, there's a relative min. Okay. All right. Again, we don't know what the y values are, but we know when the graph is going to hit that max and min. Okay. So now we're just going to write a bunch of statements to indicate where the graph is rising, where the graph is falling, and where the graph is experiencing these relative extremes. So again, these test points are not going to matter to us anymore. So if it helps, you can cross them out so that they don't distract you. We're not going to use those numbers anymore. Okay. So it says determine where the graph is increasing. So we can say f of x is increasing. So what interval would you say is increasing? Good. Union, where else? Remember, we don't use 2. Oh, 1. Good. Okay, 1 to infinity. Okay, so, and then it's important. We have to be able to justify our statements here. And above is how we're going to be writing our because statements. Okay, so we're going to say increasing because f prime is greater than 0. Okay, f prime is greater than 0. That indicates positive slope. Positive slope is going to indicate increasing. So next up, f of x is decreasing. Okay, which interval is decreasing? 6. Well, yeah. And the reasoning is because f prime is less than 0. We said there's relative max, right? So we'll say relative max at where? -6. Now, let's say I want to find the ordered pair. How would you find the ordered pair of that physical location on the graph? To the good original. So original will be location. I'm going to do the math for us right now. So if we're plug -6 in, we'll get a y value of 51. So the graph is going to be all the way up at 51 for that y value. Because there's also because statements for relative max, and the because statement is because f prime changes from a positive to a negative value. Okay, and what can we say about 1? There's a what there? Relative. Say it again. Minimum, yeah. So you can, the arrows are kind of indicating how the graph is moving, right? It's going to fall, it's going to hit a valley, and it's going to rise again. So that valley shape is going to create a relative minimum. So we'll say relative minimum at Sometimes I would just ask you for the x value, but if I asked you for the order pair, you would take that 1 and put it back into the original function. But right now, I'll just do the math for us here. It's going to be negative 6.167. But I just want us to know where and how to look for that y value. Because, what's our reasoning? I do want to point out the because statements. Students tend to do pretty good about these two because statements, but for some reason, these get left out when on tests and quizzes. So just be aware that max and mins also has their own because statement. Also, whenever you are writing your because statements, make sure that you don't just say sign changes. Okay, that's not clear enough, or the graph changes, or the slope changes. You have to name whatever graph you're referring to. Okay, so if you say graph or sine or slope, that's not going to be clear enough. Next page. Okay, same process. We're going to go through our slope sine line. So we're going to find the derivative, find critical points, populate our slope sine line, and then write our intervals of increase, decrease. And if there's max and mins, we'll find them as well. Yeah, we got to go through quotient rule here. But before we do quotient rule here, what do you notice that is something that you know is going to live on the graph? Yeah, there's a vertical asymptote. So there's a vertical asymptote at x equals 3. Is it possible for the graph to experience a relative max, relative min at a vertical asymptote? No, right? If the graph doesn't exist, right? So there can't be a graph, there can't be a max or min. But it may still show up on your slope sine line, and it's okay. Okay, it doesn't mean that every point on a slope sine line means there's a relative max, relative min. But sometimes vertical asymptotes show up even though it has no chance of being a max or min. It helps separate your intervals of increase, decrease. So if it shows up, then you can just put them onto your sine line. But it's also good to know that even if the graph goes from rise to fall, if you know there's a vertical asymptote there, you'll never say that there is a relative max or min there. Okay, so just be aware. It's nice to have a visual connection with the graph, and then we'll just keep that in the back of our heads. So if I want to find interval of increase, decrease, and if there's any relative max min, it has to come from f prime. So like you said, we have to go through quotient rule. So f prime. So f prime g minus f g prime all over g squared. Okay, what's f prime? Keep the g, and keep the f. Okay, g prime all over g squared, x minus 3 squared. When you clean up your derivative, we're not changing the denominator, right? We're just cleaning up the numerator, and that's it. Okay, so there's my derivative, negative 17 over x minus 3 squared. Okay, where do we look for critical points? Numerator and denominator. Doesn't mean that we're going to find it in both places, but we need to look in both locations. Anything from the numerator? If I set that equal to 0, there's no variables, right? What about the denominator? X equals what? 3. Okay, but we know that this is going to go on the sine line, but we also know it's a vertical asymptote. So we want to just have that picture in our heads. So here's f prime sine line. Find test points. Okay. Put it into the derivative. Negative 17 over anything squared is always going to be what? Positive. So negative 17 over negative 3 squared, it's going to be negative or positive, which is negative. And if I plug 4 in, I'm still going to get what? Negative or positive is negative. So there's only one statement that we can make, which is what? Interval decreasing. Yeah, there's no interval increase. There's no relative max. There's no relative min. But can I merge these together and just say negative infinity to positive infinity?
No.
Okay, there's a break here. My suggestion is always separate your intervals. Sometimes it's possible to merge intervals together, but then you're never going to get points taken off if you separate intervals that could be combined together. So I would just say always separate your intervals, and that way you never have to, that just takes another, one less decision that you have to make. So we'll say that our function is decreasing. And then we don't want to use the test points anymore, right? These test points are not going to matter. Negative infinity to positive 3, and a union 3 to infinity. And then what's our reasoning? Because get less than 0. No relative extrema. It says locate relative extrema, but we don't have any, so no relative extrema. Okay, we'll skip example 3. Eventually, we're going to talk about how to interpret an f prime graph, a derivative graph, but we'll save that for later. So go to page 16. All right, so for the rest of class, we're just going to practice through this page and create our f prime sine line, and then write out our statements of increase, decrease, and if there's a relative max or min, we'll write those out as well. Okay. So start with 19. Find f prime, set f prime equal to 0. So I'm just going to work on this as you guys do it. So I'll work at the same time that you guys try. And then you guys can use your calculators for this unit as well. Questions with 19? Okay, same process, 21. Okay. 25, there's a fraction. What can we do so to avoid that fraction? Yeah, push that 5 out as what? Divided by 5, the same thing as multiplying by 1/5. So take 1/5 and distribute it through the numerator, and that can be your power rule terms, and that way no fractions and all the coefficients will just be a number in front. Okay, everybody okay with 21? I'm running out of room here, so I'm just going to indicate the increase, decrease without the because statements. But because statements are just going to be the same. Again, the way I find the y values for the relative max, relative min, I'm going to take the -1 and 1 and insert them back into the original function to get those y values. Oops. Not those points. Uh, 29, I got to go through what rule to find the derivative. Chain rule. Again, keep reminding yourself that these test points are not going to show up in any statements, right? You're just using what was originally on your sign line. $33, we do need to bring that X up to the top to get it ready for power rule. And then we do need to get this to be into one common denominator fraction before we can look for our critical points. I'm just rationalizing the denominator to make it more familiar. This is around like negative 0.7. We just recognize that from unit circle value, so but you don't have to. I just looks for more familiar that way. If I put -1 in, I get positive over positive. If I put -1/2 in, I get negative over positive. 1/2 in, also negative over positive. Put 1 in, positive over positive. Okay, so tomorrow I'm going to check pages 16 and 17. So just 2 more problems to do. I think we can probably get through a good chunk of it. 5 minutes remaining, so see if we can do 13 and part of 19. So just page 16 and 17. We did 16 together. You just have two more problems to do.
What's the x, where we have 2 minus 1 over x squared, why does it go under the 2x squared as well?
Oh, sorry. I didn't show the full work on this one. I did common denominators here. So I forced my denominator to be x squared.
Okay.
That's 2/1. So this needs an x squared. So I multiply the 2 by x squared. Here, there's no need for anything. So I left it.
Thank you.
Okay, let's see if we can at least get through number 13. But I'll also show work for 19 if you want to get that done as well.
How do we get the,
Which part?
so the square root of 1/2 is just √2 of 2?
Right, yeah.
Okay.
You don't have to do that. I just makes it, it looks more familiar to me. That's why I did it. But it's around like 0.7.